Hello lazy students, today we're going to look at writing and graphing in slope-intercept form. What you're going to want to have on you, your notes, that foldable we made in class, pen or pencil, and you may need a calculator today. Your learning goals. I can write a linear equation when given certain criteria using slope-intercept form, and then also you can graph a linear equation using slope-intercept form. Some vocab that we need to learn today. Basically, what's a linear equation? We've talked about this before. A linear equation is a function whose graph is a straight line. We've looked at that before. A y-intercept, you've probably heard the term. Y-intercept is where the graph crosses the y-axis. So if you think of our coordinate plane here, and I have a graph that goes like this, right here would be where my y-intercept is, okay? And then slope-intercept form of linear equation. You've seen it as y equals mx plus b. But since we're looking at functions now, since we're in Algebra 1, we're going to look at it as f of x equals mx plus b. But remember, f of x is just basically a fancy way for us to write y. So technically this is still y equals mx plus b. Now, your m is your slope, because slope starts with m, and b is your y-intercept. So you're going to want to keep that in mind when we're continuing doing this problem. Let's make sure we know where our slope and y-intercept is. So my slope in this particular problem would be 5, because it's right beside the x, and my y-intercept, -2. What about this one? Who's my slope? Who's my y-intercept? Well, my slope is right beside my x, so right here at -1/2, my y-intercept is 2/3. So basically, can you identify who's the slope and who's the y-intercept? Because that's going to be what we need to be able to do. Here's when you're going to want to grab out that foldable we made in class. So it has the slope-intercept form at the top, and then it has these 3 flaps. You're going to want to open your first flap. What do you do when you're given the slope and y-intercept? Well, what you're going to do is you're going to use slope-intercept form, and you're going to substitute your slope, the m, for the m in the equation, so right in there. And then you're going to substitute your y-intercept, the b, for the b of the equation. So let's actually try that on the side there. So m is -5/4 and b is 7. So I'm going to use this slope-intercept form here. So f of x equals mx plus b. M, we were told, is -5/4. So I can plug a -5/4 in there. X plus my b is 7. So I can put a 7 in there for my b. That is done. I have plugged that in. We are good to go. I have my slope in my equation on my line in slope-intercept form right here. Now, what are you going to do if you're given a slope and just a point on the line? You're still going to use slope-intercept form, f of x equals mx plus b, and then you're going to substitute the given slope for the m in the equation, because you're going to be having the slope. Then you're going to substitute the x and y values from the ordered pair for the x and the f of x in their equation. Then we're going to solve for b, and then we're going to plug in the m and the b into our original form. Sounds a little confusing, but let's do a little bit here. So I have 3 and -1, and m equals -3. So what I'm going to first do, write as f of x equals mx plus b. Well, my m is -3. So I'm going to put -3 in for my m. Now, I don't know b. I need b. But what I can do is plug in that ordered pair, 3 and -1, in for my x and my f of x. So this is my x. This is my f of x, technically my y. So I can go -1 equals -3 times 3 plus b. So this is my x, so I put it in for my x. This is my f of x, and I put it in for f of x. Now what I can do is let's multiply. So I got -1 equals -9 plus b. Let's add 9 to both sides because I need b alone. I need to solve for b. Well, that's 8 equals b, right? Because -1 plus 9, that's 8. So now what I can do is take this b value I found and pop it up into here. So I'm going to get f of x equals negative 3x plus 8. Right there. What do you do if they're only going to give you 2 points? Well, what you're going to do is you're going to use your slope formula that we learned about on our last video, that y2 minus y1 equals x2 minus x1. Then you're basically going to complete what we did in the last tab. You're going to use your slope-intercept form again, mx plus b, and then you're going to plug in the m for your slope, x and y values for the x and the f of x, solve for b, and then substitute them into f of x equals mx plus b. Let's try a problem. So I have these 2 points. I have 4, negative 1, and 6, negative 7. Very first thing, let's get the slope. So I got x1, y1, x2, y2. So my m equals y2 minus y1 over x2 minus x1. So I got negative 7 plus 1, because a negative and a negative make a positive, right? So that's negative 6 over 6 minus 4, which is 2. So my slope is negative 3. So let's plug that into my slope-intercept form. Now what I can do is I can pick one of these points. Either of the 2 points will work. Doesn't matter which one, you're still going to get the same answer. I try to go for the easier math. So like this one, 4 and negative 1. Those are smaller numbers. So this is my x and this is my f of x. Because remember, f of x and y are the same thing. It's just y in disguise. So I got negative 1 equals negative 3 times 4 plus b. So multiply here. Negative 1 equals negative 12 plus b. Right? Because negative 3 times 4 is negative 12. Let's add 12 to both sides. Cancels out. Left with b. Negative 1 plus 12 is 11. So now, take this business, plug it in up here. So I get f of x equals negative 3x plus 11. And I have found the equation of my line that passes through the points 4, negative 1, and 6, negative 7. Good way to check. You can plug these points in for your x and your f of x, and you should get a true equation, aka both sides should be equal to one another. What about graphing? Now, a few of you really tried to do this already, so this might be old news, but please make sure you listen so you know what you're doing. First, you're going to want to start, so some steps, start at the y-intercept. Okay? So let's start at my y-intercept here at 4. So I'm going to put a dot there. Now what you're going to do is you're going to go from the slope, you're going to use that to get to your next point. So use slope to get to next point. So let's go down 3, 1, 2, 3, over 1. Same thing again, so I can get a nice full line. 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. Let's go back up here, fill that in as well, so I get a nice straight line. So now it looks like I gotta connect the dots here. There we go. So now, what you're going to want to make sure you do on any line you graph for Miss Marsh, you're going to want to make sure you have some arrows on the end. Now, your arrows can look like this. They can look filled in. Just please, please, please make sure, because these lines do go on forever. So you do need to make sure you fill in arrows on both sides telling me that you know they go on forever. Here's the reason. When you continue in your math career, some equations will not go on forever. So you need to make sure you designate that these do. Otherwise, technically, you're not graphing the correct equation. So please make sure that there's arrows on the ends of your lines for all these till now. Okay? Let's try it again. So I'm going to start at my y-intercept, -1. So on the y-axis, I'm going to put a dot at -1. Then I'm going to use my slope, which is 2 over 1. So I'm going to go up 2 to the right 1. Then we'll do that a bunch of times here so I get a nice full line. Then I gotta go down 2 over 1 because that makes it in a line. Now if you kind of notice, I'm making a positive slope. That's a good way to check to make sure your line is being graphed correctly. Because I have a positive slope, my line should have a positive slope. Let's put my line together here. Connect my dots. Whoa, little off. That's okay. And then put my arrows on the bottom, put them on my line here. There we go. I have now graphed my equation f of x equals 2x minus 1. And that's the end of this video. See you later, Sabers.